This is lesson 6.3, rate of change and slope. The table shows Stephanie's height at ages 9 and 12. What is the change in Stephanie's height from age 9 to age 12? Well, at 9 she was 53 centimeters tall, or inches tall, and at 12 she was 59 inches tall. So 59 minus 53. Her height changed 6 inches. She grew 6 inches. Over what number of years did this change take place? Well, from 12 to 9 is 3 years. Write a rate that compares the change in Stephanie's height in inches to the change in age in years. So this is inches per year. We simplify that to 3 over 1, and that means that this is a unit rate because the denominator here is 1. It means Stephanie grew 3 inches per year. That's her rate of growth. A rate of change is a rate that describes how one quantity changes in relation to another. A rate of change is usually expressed as a unit rate, as we did here. Find a rate of change from a table. The table shows the amount of money a booster club made washing cars for a fundraiser. Use the information to find the rate of change in dollars per car. Well, for every 5 cars, you can see in the table, the amount of money made increased by $8. So it's the change in money, which is 40, and the change in cars, which is 5. So for every 5 cars, the amount of money increased by $40. If we divide 40 and 5 by 5, changes to a unit rate, we see an increase of $8 per car washed. The table shows the number of miles a plane traveled while in flight. Use this information to find the approximate rate of change in miles per minute. So as we go from here to here to here, we see that the change in time is 30 minutes. If we go from here to here to here, we see that the change in miles is 290 miles. We can simplify that by dividing by 10, which leaves us 29 over 3. If we go to a unit rate for that, we get 9.6 or 9 2/3, which is approximately 10 miles per minute. 10 miles per minute. Find the rate of change from a graph. The graph represents the distance traveled while driving on a highway. Use the graph to find the rate of change in miles per hour. To find the rate of change, pick any 2 points on the line, such as 160, 160, and 120, and then determine the change in miles, in this case 120 minus 60, and place that over the change in hours, in this case 2 minus 1. So we get a rate of change from the graph of 60 miles per hour. In our example, use the graph to find the rate of change in miles per hour while driving in the city. And again, we'll just pick any 2 points. Let's do 3 and 90 and 1 and 30. So our change in our x value is 3 minus 1, because we go from 3 hours to 1 hour, which is 90. And our change in y, or miles, is 90 minus 30, which gives us 60 over 2, which we further simplify to a unit rate of 30 over 1. So our rate of change in miles per hour while driving in the city is 30 miles per hour, rather than 60 as it was on the highway. Finding slope. The table below shows the relationship between the number of seconds, y, it takes to hear the thunder after a lightning strike and the distance x you are from the lightning. Graph the data, then find the slope of the line. Explain what the slope represents. Again, we're going to use change in x over change in y. In this case, we're using 5 hours, or 5 seconds, I should say, and 3 seconds. the distance is actually 5 miles and 3 miles. The seconds that it takes the sound to travel is 25 for the 5 and 10 for the 3. So 25 minus 10 over 5 minus 2 gives us 15 seconds for 3 miles. We simplify that further to a unit rate of 5 over 1. So for every 5 seconds between a lightning flash and the sound of the thunder, there is 1 mile between you and the lightning strike. Notice that the graph in example 2 about driving on a highway represents the rate of change of 60 miles per hour. The graph in Check Your Progress about driving in the city is not as steep. It represents a rate of change of 30 miles per hour. The constant rate of change in y with respect to the constant rate of change in x is also called the slope of a line. Slope is a number that tells how steep the line is. Notice that the steepness of the line here is greater than the steepness of the line here because the speed is higher. Slope is the rate of change between any 2 points on a line, represented by the change in y, which is the vertical change, over the change in x, which is the horizontal change. This is a key concept. Check your progress. Graph the data, then find the slope of the line. Explain what the slope represents. Here's our graph. Water loss per week. I've already graphed the line. I'm going to pick 2 points on the line. I'm going to do 4, 6 for this one. And I'm going to go down here to 2, 3. Gives me some whole numbers. So my change in my x is from 4 to 2. 4 here to 2 here. My change in my y is 6 here, 3 here. So 6 minus 3 is 3. 4 minus 2 is 2. Which means I have a slope of 3 over 2, or 1.5, if I want to write that as a unit rate. What that means is that I lose water at the rate of 1.5 centimeters per week. Use the information in the table to find the rate of change in degrees per hour. Well, my change here appears to be consistently 3 degrees. Here it's 2 hours. So I have my degrees is going to be my y value, so I'm going to do 63. I'll start at one end. I'll do 63 minus 54. And then from 12 p.m. to 6 a.m., that would represent a change of 12 minus 6. So what I get here is 9 over 6, which simplifies to 3 over 2. So for every 2 hours, I get a change in temperature of 3 degrees. Again, I could write that as a unit rate, which would mean I would get a rate of change in temperature of 1.5 degrees for every hour, which my graph does show, or my table shows. In number 2, the graph shows Benito's distance from the starting line. Use the graph to find the rate of change. Well, they only give me 2 points, so I have to use those. My change in x is 3 minus 1, because my x value here is 3, my x value here is 1. My change in rate, or change in y value, or vertical value, is 1.5 minus 0.5, so that's 1 over 2, which represents a change of 0.5, or a half a mile per second in terms of distance from starting line. The table below shows a number of small packs of fruit snacks, y per box x. This is my y value, this is my x value. Graph the data. I've already done that. Packs on my horizontal, or my vertical, boxes on my horizontal, which is my x value. This is my x-axis here. This is my y-axis here. Find the slope of the line. Again, I'll take 2 points on the line. I'll just use this one and this one. My change in x is 7 minus 5. My change in y is 56 minus 40, which gives me 16 over 2, which gives me a unit rate of 8 over 1. that means that I have 8 packs, or yes, 8 packs per boxes of snack. 8 packs per box of snacks. The only vocabulary in this lesson is rate of change, a ratio that shows a change in one quantity with respect to a change in another quantity, usually remember written as a unit rate. And slope, which is the rate of change between any 2 points on a line, the ratio of vertical change, which is the y value, to the horizontal change, which is the x value. At this point, you should quit the video, go to my Moodle page, log in, take the lesson quiz 6.3,